Welcome back to another episode of Tech Unraveled, the podcast where we dive deep into the latest advancements in technology and explore their real-world implications. I'm your host, and today we're exploring a fascinating intersection of software development and formal verification with the project called coq-of-rust. So let's start off with a little context here. Rust is already known for its robust type system that helps prevent common programming mistakes, such as memory errors. However, it turns out that even with all its advantages, Rust isn't completely immune to bugs. Things like unexpected panics or inconsistently applied business rules can still slip through the cracks. That's where formal verification comes in, a method of mathematically proving that software is bug-free. Sounds pretty neat, right? Now, coq-of-rust is a tool designed to translate Rust programs into a proof system called coq. The big promise here is that once your Rust code is translated, it can be verified using standardized proof techniques. Imagine being able to check every single execution case of your program, ensuring it's absolutely bug-free. That's what coq-of-rust aims to achieve. Let's dive a bit deeper. Picture this. You've written a simple function in Rust. Let's say it adds 1 to a number. When you run this function through coq-of-rust, it transforms not just the logic, but does so in a way that's comprehensible to coq. That means you can then create specifications and verify that your code meets those specifications, effectively translating your confidence in the code from human judgment to logical proof. It's like having a supercharged safety net for your applications. Now, for those curious minds out there wondering about the process, here's the workflow of coq-of-rust. First, you feed it your Rust code. The tool translates it and goes through a couple of refinement steps before it's ready for formal verification. It's like a refinement course for your code, honing its ability to withstand scrutiny. Finally, you can specify conditions that the program must meet, and voila, you get proofs that ensure your code is reliable. But let's not forget why this is essential. This kind of verification becomes crucial in systems where bugs can lead to catastrophic failures. Think smart contracts or banking applications. We're not just preventing a little bug from causing a crash. We're talking about building software that can stand up to the scrutiny of state-level actors. Now that's quite a responsibility. So here's a thought-provoking question. If a tool like coq-of-rust can promise 100% bug-free code, does that change how we think about software testing and assurance? Do we still need to write traditional tests, or should we move towards this mathematically rigorous approach? Just something to ponder. Before we wrap up this enlightening discussion, let's touch on some exciting alternatives in the formal verification space for Rust. Projects like Aeneas and Hackspec v2 are pushing the envelope even further. They delve into functional programming translations and provide different methodologies to ensure code safety. So, to summarize our chat today, coq-of-rust opens up a new frontier for developers and underscores the necessity of formal verification in creating robust software. With this tool, we're not just fixing bugs, we're proving our code is bulletproof. Thank you for joining me today on Tech Unraveled. I'd love to hear your thoughts about formal verification tools or even your experiences coding in Rust. Drop me a line or leave a comment. Until next time, keep innovating and stay curious.